Welcome to another episode of the Data Engineering Show. With us today, Stephen Moy. Glad to have you with us, Stephen. Thank you so much for joining. Stephen is a software engineer at Yelp. I don't think Yelp needs any further introduction. I think we're all just super happy that now with vaccine spreading, we can all go back to using Yelp and being overly critical of restaurants and businesses and giving reviews and laughing about reviews that are funny and being excited about just seeing stuff and experiencing things in the world. But Stephen joined Yelp in 2011. I think that's correct, right, Stephen? More or less?
That's right, the first round.
Throughout the years, you've always been close to data-heavy projects, I think. You're an expert in query engines and performance. I urge you to check out what Stephen has been writing on LinkedIn on this subject. Very interesting stuff. I think we're all, as data enthusiasts, are a little bit envious of people like Stephen who work on cool and interesting data sets, like the data sets Yelp has. And we'll talk about that. Stephen, anything you want to add or I missed about yourself?
No, that's kind of a good background of me. So I've been pretty close to data. When I first joined Yelp, I was a web developer, mostly working in backend, so get to see the growth of our OLTP database in MySQL. And then quickly, like everyone else, you want to get insights from your data. And if you're trying to do data analytics on MySQL, your database administrator will quickly find you and ask you kindly, you better not take down my database. And you need to find solutions. And at 2013, Yelp was already using MapReduce. But it's not great because every time when someone wants to get an insight, they're like, how am I going to write a MapReduce job just to find this one thing? You go through a lot of development cycles. And quickly, we land on a real data warehouse. In fact, we start on a cloud data warehouse at AWS. And that started our journey on the OLAP space.
So to get warmed up and understand sort of the Yelp environment in terms of data, how much data more or less does Yelp deal with?
We, like every company, we have lots of different streams of data. For example, when you're using Yelp, we want to make sure that we provide you the right recommendations. So for that, we need to understand how our users are using our property. So we, like everyone else, we have an event streaming model. So what happens is, as you're using features on the site, we'll log events. That will go through Kafka, and then from Kafka, we'll forward it to multiple of our many data stores. Depends on our use case scenario. One of them would be the data lake. It's an efficient way to store the data. Not exactly as efficient in terms of when you want to use it and make it really fast. So we also stream the data into a traditional cloud data warehouse as well.
Which cloud data warehouse are you guys running on?
It's no secret. Yelp has been using Amazon Redshift for many years now. They are a great partner with us. We have given them a lot of feedback, and they have moved their feature set a lot in the past few years as well.
You talked about some of the history of your data stack and your pains in the MySQL days. How many years ago was it when Redshift was implemented, and sort of what was the tipping point at the time that drove this?
Yeah, actually, it's a very interesting story. So at Yelp, we once also have our startup days, and I joined the company in 2011. So the very first, the so-called data warehouse solution was in 2010. And what happened is, of course, like many successful web company, our OLTP space, we have the leader database, and then we have replicas. And what we would do is we'll have an analytics-specific replica, and people will run their queries on it. And what happened is, quickly, as we brought more analysts on board, their queries will take too long to run. And this is a very funny story because what happened is, as your analytic queries are running slowly on an OLTP, even replica, yes, it's not affecting your main database traffic. For example, the website's still running. However, the replication will actually slow down. And our DBA team actually will get paged when application is too delayed. And, suddenly they're finding themselves being paged all the time. And of course, that's not really acceptable for organization to run our production fleet. So our DBA gave a book to one of our new engineers to say, yeah, this is a book about building data warehouses. Please build us a data warehouse. That is how we first got our so-called data warehouse on a MySQL analytics specific replica. But very quickly, what people have found is like, you can just not throw enough hardware. Like you keep scale up. And actually at that point, Yelp still run on co-location. So we have to provision our own hardware. And you can imagine the arduous process to provision more beefier database hardware at that point. At that point, there was a buzzword called MapReduce, introduced by Google around 2007, 2008. So we jumped onto the AWS EMR stack. So EMR is an elastic MapReduce. So we will spin up those transient clusters. We'll do our data mining, running MapReduce. We'll first export the MySQL data into S3, and then we point Hadoop at it. It actually was pretty good because suddenly you have all the power, the compute capability because it's elastic, and to do all this insight. It lasts us around 2013. And I actually have a great story to share because at that point, no one's really talking about data warehouse because,
people were exchanging physical books back then. It was like...
It's funny. It's like, because it's such an expensive asset, right? Before the launch of Redshift, let's say if you want to do a data warehouse, you go to any of the big people, the Teradata of the days, you will be like, yeah, sign me up. They'll be like, well, would love to. Did you bring your checkbook? Okay, how much is it? Initial implementation can easily cross $1 million mark. And like any startup, we're like, whoa, like what? We don't get to use the product. We have to already pay $1 million.
Does it include the track that gets the hardware?
I don't even know, like, for example, even if we hand the check, how long would it take for that rack of hardware to show up? And now we have to go figure out how to plug it into our co-location space. So at that point, Redshift launched around, I believe, like 2011. I think that was when they start betaing with the customers. And, at that point, we felt like we really wanted a high performance data warehouse. And when we come across this product, it's like, oh, pay by usage. So you mean that we can just try it out? If it doesn't work, we can just walk away. Why are we not using it yet? So very quickly, actually, my team, at that point, was the first team that start ingesting our event stream data into Redshift. And once we put up the data ingest into it and we let our analysts to use it, they're like, what did you do? Why is the code that used to take hours to run just get run in like less than a minute? Like they're just blown away. They're like, this is great. This is done, right? Like we're going to use this for production, right? Now, of course, there's still, it took us another 9 months to productionize everything. But that's, when Yelp got started with Amazon Redshift around 2013.
In terms of headcount, without going into the specifics of the departments, how many people at Yelp deal with data initiatives?
That's always a very vague line because technically speaking, every team that needs to drive insight, they have their own share of data. In fact, I would say, both a data dialogue and also a silos because, every team needs to build their uniqueness through the use of data. So, everyone is involved, but we don't look at the same data. I think that is where the deluge comes in because oftentimes when, everyone, a team A versus team B got very excited about what the initiative they want to do, they will often bring in, their charts and board. And then, team B was sitting quietly, they would ask some question, but then, oftentimes after the big giant meeting, they would get together, have coffee. They're like, that graph, we have questions because we got something very similar, but it actually, we thought it differently. And, then suddenly everyone found like, oh, we were using the A prime copy of the production database. And then someone was like, oh, we're using a double A prime copy of the database. They're like, what? Like, how did you get that copy in the first place? So that has been, let me answer your question is, like, in terms of a team, yes, we had a team that would power, for example, the analyst. And that team is small, maybe 5 people. But for the engineering organization, I would say more than half the organization actually do need to derive insight from their data. But, they don't talk about it because they just take it as a day-to-day activity. They wasn't even thinking about it as an initiative.
So what kind of use cases do you do over the data? Share with us some of the leading use cases.
Yeah, for example, we're Blast. We are a crowdsourcing content, so it's user-generated content. And one of the things with the advent of more powerful smartphone camera is we get lots of great photo contribution. In fact, one of our VP of engineering is a big photo buff. He will bring his DSLR and he will go snap photos like no tomorrow. And and he will like go, oh yes, I this month like all my photos were like the top container of the most viewed photos. Now, we get all these photos. Now what? So one suggestion from one of the engineering team is like, hey, oftentimes when you're looking for a restaurant, what's the favorite? Or you sit down with your friends, you're like, what should we order? And what the angle we have is we decide to use machine learning to find out what is the most popular dishes of a restaurant, both through the amount of photos people contributed and the reviews they have written, to go figure out like how we surface those great dishes, popular dishes, from the high quality photos that our users contribute to. So that's one example that is like very unique in our space.
Amazing. And which teams were involved there? I mean, there's a data science team, I imagine, data engineering, software engineering. How does that kind of end-to-end project go through?
Often this project, it takes some spark. Sometimes we would have the feature from the product managers, but I think this one particularly was from one of our hackathon project. So like many other tech companies, we also have our hackathon at Yelp. And, someone suggested, we should do something with our photos. So at a hackathon at Yelp, it used to be 2 days. It happens about 3 times a year. Now, because of we're doing virtual hackathon, it's lengthened. So we have 3 days. And I remember when the feature was, put together during a hackathon. They put together a team. We got front end team, back end powers, and we got product managers onto the hackathon group. And they were trying to figure out like, how should we build these popular dishes? And I think, the first, what we do after a hackathon is we have like science fair presentation. So people would put the table when we were all still back together, we'll put up all the tables on our social floor. Everyone have a little booth, they prop up their screen and they were pitching, look, in San Francisco, what are some of the popular dishes of those very popular restaurants? And, of course, in 2 days, you got to take a lot of shortcuts. But there was some very preliminary ranking algorithms they've done. And, of course, Jeremy walked by. They're like, wow, this is amazing. We got to ship this. And, of course, then, it's a much more, a flesh out process. We engage both our machine learning team. So in this case, the popular dishes is actually reside in our content understanding team. As you can imagine, our very unique specialty is sort of the user-generated content. So we have a content understanding team to put, to bring semantics into, the both the review contribution and our photo contribution. And we have a lot of machine learning engineers in that team, but oftentimes, we actually have a core machine learning team as well. So they would talk to them in terms of sort of what foundation facilities they can use. And they did also, in order to first evaluate sort of their ranker, they also have engaged with data science. So in Yelp, data science is a pretty big org. And what happened is we trying to match data scientists with the various groups at Yelp. So as an engineering group at Yelp, you will actually get matched to sort of your data scientists. I think the ratio sometimes would be 1 data scientist to 2 teams. So, they would say, yeah, this is sort of our preliminary, like very vanilla ranker. And, the data science work with them to say, oh, okay, well, let's explore sort of like, what are some of the existing model or would some of the past prior art that will work for them. And we, of course, then they prototype. Then what we do is we do very rigorous A/B experiment. In fact, Yelp itself has published a lot of methodology of how we do A/B experiments. And that's how we A/B tested, which ranker algorithm will get better traction in terms of the content that it picked.
We talked about Kafka and Redshift. Tell us a little bit more about your data stack. What other technologies are used there?
Yelp's a pretty long company now. We accumulated our share of data storage technology. Let's see if I ramble off the list. Now, in the OLTP state, we got MySQL. It was always this database that run our website and properties. You may not know we actually have Postgres as well. I can't actually tell you what that Postgres database is for, but we have both. Of course, the audience may remember the big debate in 2010. Web scale database may have flown the wire. We may have dabble our toes into MongoDB. There is a couple MongoDBs, floating, but I would say they are not very close to running the website, but they are important to us. Key value store, we actually also use DynamoDB. I think that will be one of our first managed database offerings we've used actually on Amazon because of the ease of use. You can imagine we actually have what we call the database reliability engineering team, really focusing on the domain expertise on databases. But through this long history of teams have trying out various technology, we have accumulated quite a bit of storage technologies. And, DynamoDB was a unique situation where a team where they really need this very low latency key value store. And at the time, we do not have the domain expertise of something like Cassandra. We actually have moved a lot of our low latency key value usage to Cassandra. So we actually have a dedicated, in our DRE world, we will have the DRE SQL team that really focus on the SQL side of things. And we have the DRE NoSQL that focus on, for example, Cassandra. So those are some of the flavor of the technologies we have. So the OLTP space. Now, on the OLAP space, of course, we have already mentioned Amazon Redshift. And in fact, in 2017, when my second time to join Yelp, I took a 2-year break in between 2015 and 2017. So when I come back, we were using a lot of Redshift. And I think that is, if Redshift works so well, that's no problems. At 2017, it actually has become a challenge for us. Redshift is so good, and we were using it so much. Someone knock on our door and say, "Hi, the team that uses a lot of Redshift, can you help us to project, where the cost will go in the next few years?" And we draw out our accelerator curve, and our finance counterpart asks us like, "I think you want to innovate there because that curve growth was, let's just say, not very expected for our finance partner." So at that point, the world also have pivot. Like we earlier mentioned Hadoop, right? I think around 2015, the Hadoop community have sort of, or many industry Hadoop companies have kind of saw this coming is they got to innovate because Hadoop is not very sexy at this point because you got those cloud solution of data warehouses. And it turns out most people would want to interact with their data using SQL, not always bust out a MapReduce program. And, they now have bring in this new, I didn't know then, but at that point, this new phrase called the data lake. Let's use our HDFS investment and make something out of it. So, there are solutions like Impala is an open source project that was funded by Cloudera that really take the people's existing Hadoop investment and then trying to put a SQL layer on top of the data, but not throwing the traditional MapReduce. And they got a lot of adoption there as well. And Yelp, actually, we never fully invested in the Hadoop ecosystem because for us, we like the serverless aspect of our analytics stack. Earlier I mentioned we were using EMR prior to Redshift. So our Hadoop cluster are all transient. So you boot it up, use the compute capability, and then you tear it down. So which means we actually already are storing a lot of our data on S3. Now, as the audience know, S3 gives you 11 nines of availability durability. You don't really have to worry about that. You store something in S3, you may lost it. So a great place to store your data. And Yelp was already using S3 in terms of storing our event streams of our logs. But of course, before 2017, most of our logs in gzip to JSON. And if you ever work with gzip to JSON, first is you got to bring the data from the wire. Then you can, as a stream, you can unzip them. Then you can process them. And, what we were doing, because it's JSON, even if you're looking for only some of the keys that really matter to your analytics, you still have to, read the whole data streams, to pick out the data. And in 2017, other pioneers like Twitter and Cloudera, they have kind of proposed this storage format called Parquet. Parquet is also an open source project. It's inspired by Google's Dremel project. And Dremel is the internal code name for Google BigQuery. And even at the time in 2011, when Google was, published some of the paper of the Dremel system, people were like very excited, especially actually at that point at 2013, our VP of engineering is actually an ex-Googler. So, he will make reminiscent of, if I have Dremel, all these things will be so much easier. And, some of the basis of the Dremel technology is, they also store their data in a columnar fashion. They stuff it into the Google file storage systems. Nowadays they have a new iteration. But then all the compute facility, you're still writing SQL interacting with the systems, but all the compute facility is transient. You don't have to think about servers. So at 2017, looking at our ever-growing Redshift build, we're like, oh, let's build this data lake thing, because all these other companies are really pivoting in this field. In fact, yours truly get to lead a team of 3 people to build a data lake solution for Yelp in the next 3 years. So Yelp launched our data lake around 2019 internally, and we store all of our event stream data into Parquet, and then they will be stored on S3. As I mentioned, you will still need a catalog. For us, we use the Amazon Glue data catalog because we don't actually have a Hive solution in-house. So we just use the data catalog. And that allows us to connect both to Amazon Redshift using Redshift Spectrum. And also at that point, there is a Amazon Athena product, which is a variant of the open source PrestoDB project. And of course, like any ML organization, you kind of can't get away from Spark, since Spark also have very good connectivity to S3 and with Parquet. Our data mining teams are also now using Spark to mine directly from the data on S3 via Parquet.
So you've seen how essentially all the technology stack we all know these days evolved over time, little by little, took it on yourself, hands-on. Awesome journey. Now we're going to do a kind of a Blitz question round. So
Sure.
Short answers. I'm going to just go with the flow. So
Sure.
You ready?
Yeah, let's do it.
Commercial or open source?
Depends.
Batch or streaming?
Streaming.
Write your own SQL or use a drag and drop visualization tool?
We do both.
Work from home or from the office?
I like both.
You have to be more decisive.
All Boolean answers. Supposed to be Boolean answers.
No, actually, I'll tell you a joke. Regarding Boolean values, it turns out when you tell people there's a Boolean, true or false, it's technically try-value because you forgot about null.
Putting nulls in a field is dangerous, it might slow things down, but you can't avoid it.
I think null itself can deserve a show.
We can add a corner, like a joke, engineering joke corner in our podcast in addition to the Blitz round corner. Okay, so AWS, GCP, or Azure?
AWS.
To DBT or not to DBT?
We are actually deploying DBT in our community right now.
To Delta Lake or not to Delta Lake?
Pass.
Okay, so that was it for the Blitz round question. Tell me, Steven, how about you share an awesome win with our listeners?
It can't get better after the
data
photos.
lake story.
Finding the most amazing dishes after the photos.
I think you always want to work backward from your customer. This is something I learned from my days on Amazon. And one of the story is we were, as I mentioned earlier, we have our event stream data on Data Lake. And it actually, one of the interesting thing is since we moved to have a lot of our data on Data Lake, we actually now have a lot of teams that will feel very comfortable just using Jupyter Notebook to explore data on their notebook. And of course, it doesn't really have to do with Data Lake itself, but with Jupyter Notebook, with transient Spark cluster, it's now very natural for teams. They don't have to worry about, I have to pre-provision resources. They would just, spin up transient Spark cluster to analyze the data. And what happened is one of the team that is building, unique features for our business owners is they want to be able to present almost like a community. If you think about you have a CRM for the big enterprise, what about a CRM for the little guy, the local business of the world, right? So we want to be able to enable that capability for our local business. Now, what happened is Yelp do have a lot of event stream data. A day, we typically easily accumulate 4 terabytes of compressed JSON data.
gzip, so it means a lot.
Yeah, it's a lot. They are compressed really well, 5x easily. And what happened is they were able to build that product. And what they find out is they were starting to, they want to be able to collect all the interaction that the users have with the local business for the individual business owner. And in order to, build up all these, features for the local business owner, they will repeatedly run this data. First, the typical curve will be, we are looking for, these types of interaction in this event log stream for some business ID, such that they can record it, such that later on our business owner, when they access the website in their business owner portal, it will just brings up right away. And what was happening is at first they was prototyping on Jupyter Notebook. When they productionize it, they need more known availability, so they actually launched their features on AWS Athena, and it's great. Athena as a ad hoc SQL query engine allows you to run a large amount of data. And what happened was, the feature was fine, it was very successful until. Again, our finance department knocked on their door to say, hi, we noticed your Athena usage through the roof. If for the audience that doesn't know, in Athena, the cost model is based on terabyte scanned. And I can't tell you the number. Let's just say now they are suddenly very concerned because the feature is very popular. So they want to continue the features, but they were getting a lot of pressure in terms of how quickly they're spending money on AWS Athena. So they come to our team and say, hey, you built a data lake. Do you have any ideas? And I think this really speaks to if you want efficiency, you got to work backward and see sort of why they were scanning so many terabytes to build their features. And it's very simple. When we issue their query on Athena, we notice that, it has certain predicates. For example, when I say predicates, they have a word clause. The word clause will say, looking at a particular event type and for a particular business ID. Now, the power of indexing or power of zone map is that if your data is pseudo-sorted, your zone map will look very nice using your min and max statistics, and it allows the query engine to skip a lot of data. And our team go ahead and started to sort out data on those predicates because we noticed that they are the biggest customer reading that data. And we sorted it based on the event types. And of course, we also bake in the business ID. So they got very quick min max statistics to hone into what the data they need to look at. And it dropped their cost to 1/100th of the original cost. And now they are happy to deliver their awesome features to our local business owners. And we deliver values to them because now they can continue to use their query because it's very magical, right? You have the same SQL query. They don't have to change any of their code. And just through the power of good data structure, good data organization, and they were able to keep their feature and everyone's happy. So there's a happy story ending there.
I wonder when is the next time you will get approached to look into another huge initiative to reduce costs because queries are costing more than expected. But and when the next architecture leap will allow to solve that?
I think, everyone has been getting somewhat addicted with elastic compute. And that usually comes, because it's very magical, right? As a small team, you can tackle, the hardest problem in this world. Only then, like the Amazon of the world is not going to stop you racking up the bill because, they are a compute utility company. It's only then, your finance side, as they are paying the bills with their credit card, they're like, yeah, we need to have a chat. And I think that is where the push and pull comes in to say, hey, you need to innovate. Like, yes, you can deliver great features, but you also need to be able to do it on a tractable way in terms of, our cost basis. And, that would drive some innovation, across the use.
Now it's time for you to stop showing off those amazing things and tell us about an epic failure.
Yeah. I'll be very honest with you. In 2017, when I rejoined Yelp and get to take on this daily project, I don't know anything about database. It was more I used to work at Yelp in the 2013 to 2015 span, and I happened to be, the team that brought up Redshift and also Elasticsearch. And, yes, I know a little bit of data, but, I'm not really a database enthusiast. And what happened is, the buzzword data lake was really buzzy. Everyone is doing it. There are some really big, titans in industry. For example, Netflix. You can see all the tech talks from Netflix. Talking about how they have built a cloud-native data warehouse completely on an S3. So we built a data lake. At this point, I actually don't even know who Michael Stonebreaker is. Now, for the audience, Michael Stonebreaker just happened to be one of the 3 ever Turing Award winner in the database space. And, if you dig into, so there's if we can put on the show note, there is a wonderful open source resource that they've written. It's called redbook.io. It is a collections of articles and also primary sources where they talk about how people put database together and what they see in the industry. In 2010, David DeWitt and Michael Stonebreaker's friend and colleague in another university, DeWitt and Stonebreaker wrote an article about how dumb Hadoop is. It's the completely wrong way because, they spent 30 years to figure out how to build database, really fast database for people to use. And people that are doing MapReduce basically throw all the other windows and say, nah, we don't, no, that's just useful. And, they got really ridiculed in the Hadoop community. The Hadoop community said, no, you pass your time, professors, you don't know what you're doing. Guess what? Google actually, I won't say they abandoned MapReduce. Let's just say even within Google today, they will jump to BigQuery first. They will not use MapReduce to write their first job. At that point, I think, Michael Stonebreaker already have pointed out, but I don't know about Stonebreaker at this point, 2017. And Stonebreaker said, we don't really know about this data lake space. Maybe it's useful. But certainly the encoding, columnar storage is a leap in terms of having data sitting at rest. But whether that is the way to organize your data, it is very doubtful. Because think about it. You have a data lake. What do you have? Essentially, you have a pseudo file system. Actually, you have a worse than file system. You do get the durability and the availability of a massively scaled out system of a blob store. But now, what happened when you want to do some of those? Let me bring you an example. A very simple API in POSIX file system, MV move. It's atomic. In fact, the atomic attribute of move is it's the linchpin of many algorithms. An atomic rename oftentimes is how you atomically do a swap and also commit some of the data to expose it to the query engine. You can't do a move in S3. That API is not available. So how a lot of the times people pretend there's a move is a copy plus a delete. So you have your data organized in a data lake. You still suddenly have to go organize your data very manually. So instead of having, your typical outer table or, a lot of the show create table, now you have a litany of objects, lying on your S3. Think about it. I think last time when I go look at how many objects is in one of the S3 bucket, is already at the 4 billion objects mark. How are you supposed to organize it? If someone say, Steven, I used to have this data, but I don't know where it is anymore. Can you help me? It is a very daunting thing to go find this object in your S3 bucket. So, I mean, and that is why, people have used database for a long time, because there are lots of, heart and sweat in terms of maintaining a native catalog in the database and allowing you to use the table abstraction to perform a lot of the operations. Now, why I give you all this story? 2017, I was basically asked to build a data lake, and I went ahead and built it. And what happened is, as you work with a customer, helping them on board, what I see is, I'll give you an example that a lot of people tell me. They are very impressed. Now you have this infinitely scalable storage and you can query anything and everything is burstable. They ask me one thing, because whenever I onboard a new customer, there's one thing I taught them, and I make sure that I reminded them. Hi, so in this ecosystem, we really want to ask you that whenever you write a query, please make sure your predicate uses the partition key. So they stare at me. They're like, Steven, what is a partition key? I was like, that's a great question. So a partition key for a data lake oftentimes is for data that, in order for the query engine to prune a lot of data out, they use perhaps a prefix. For us, most of our data is time series data. So we use a partition key called DT. They are just date, 2020, 0201 for February 1st, 2020. That's naive, but it's actually very counterintuitive. Now, for example, why is it counterintuitive? In a traditional data warehouse, you may have a sort key. And of course, naturally, your event time is your sort key. So, many people that are using data warehouse solution are already accustomed to, of course, I should write my query that uses the event time. Why isn't event time the partition key? Your cardinality is too high. Your event time is typically millisecond, or even worse is second. The cardinality is too high. What do you mean by cardinality too high? Imagine, so the so-called catalog is actually also powered by a relational database. And imagine your index that has billions of entries. It's still actually, not only that you go first seek to where the range you care about, because a data catalog like in Glue or the traditional Hive data catalog, you still have to go scan the prefix to find out what objects you need to work on. And that could take a long time.
The index scan takes most of the query's time. And because you let as you said, the Postgres or the operational database that drives the metadata actually do the index scan. So that is can be very painful. Absolutely.
Yeah. And, for the user, speaking back to the partition key, for them too, is a very laborious concept, because they say, so all my original queries are using event time. So of course, I'm going to start there. And now you're going to tell me to go add this partition key predicate. Fine, they would do it. For a simple query, that seemed very reasonable. The queries that I typically come across with my customers are easily 300-400 lines. Predicates are basically many predicates.
50 predicates.
Easily, right?
Yes.
And now you're telling them, please, let's say, it's easily a 10 table joins. You tell them, for each of the table join, can you make sure you add the corresponding predicate for those 10 tables? You can see the eyes start, the pupil growing bigger. And, I know I have a problem, because it is literally hurting their mind. Yes, can it be done? Of course it can be done. They are capable analysts. But it's wasted work. You are making them to change how they think about approaching a space that they're very familiar with. And suddenly you're jamming this foreign concept. And the worst thing is, your partition key is only efficient based on your query pattern. That means that sometimes as the administrator of this data lake, I need to go change the partition key because how people uses the tables changes. And now what? Because I have exposed this concept of a physical partition key, every time I change them, I send some nice Slack messages like, hi, I know you have this query that you haven't touched, they all runs. Can you please rewrite them to use this new partition key we're going to introduce? I can literally virtually witness like the virtual pitchfork that they want to stick onto my
Some
rear.
people definitely hated you back then.
You can say yes. And I would say, despite we built a successful project in the beginning and gained a lot of adoption, I actually think of this as one of my greatest failures because, yes, we built a scalable system, but we literally have forgot the usability of our customers. And I would say everyone now is busy trying to dig ourselves out of that hole.
What's the top challenge for Yelp's data initiatives these days?
It's not my idea, but I think from ThoughtWorks a couple of years ago, there is this idea of a data mesh. And I'll kind of briefly touch on what a data mesh is. The author of the paper, I think, is from ThoughtWorks. And what their observation is in an enterprise with many people that use the systems, typically the classic way is you will have a team that is your emissary. They know how to deal with the physicalness of how to organize the data, and they also understand the customers that are just using SQL to access the data. And because people are accumulating new types of data so quickly, your bottleneck is really on this centralized team. And I would say it is actually very difficult for a centralized team to have all the understanding of the domain-specific data. They don't really know, like, oh yeah, this table is full of sparse floats. Why is this full of sparse floats? Well, machine learning people really like sparse floats. That's all they like about.
Find the engineer who put in the array inside the JSON inside the variant field.
Right. And there are the types of data that are very dense. In fact, there are a lot of trickery you can do when they are very dense array columns and arrays. And because they don't really know the domain, they are really just trying to make sure everything is sane in the ecosystem. They often got outrun by both the producers and the consumers. So the author of the paper data mesh, they propose is, hey, we feel like the technology of data warehousing, data lake, query engines, they are ubiquitous enough that why don't we let the domain data producers to organize them themselves? And using this vague, very loose interface in terms of, tables that a team-specific team want to publish it to let the organization to use it. So they call it the data mesh. So it's like almost every specific domain, they have their little data ecosystem. And you make sure that it's a mesh because that you can actually query all of them together. That's a lofty goal. Like you can see the concept, there are a lot of valid points, but when we're trying to flow this idea, is actually the most difficult part. I would say a lot of organizations, because they're running so fast, in terms of how they want to approach, maintain their data, how to track what is being used, and also how are people using it, it's a secondary thought because, of course, a lot of the time when they spend, they want to think of the next great algorithm to make the next greatest recommendation. They're thinking how to make the website fast. The organization of data is yes, they have to do it. It's very secondary. And how do you create enough tooling to really deploy data mesh in enterprises like Yelp is still a very challenging thought. But we definitely have seen running into sort of the bottleneck of only have one centralized team to handle all these data ecosystems.
That seems like a heck of a challenge.
I think that once people realize that a table is, as you said, it's just an abstraction on a bucket, and that a database is just a logical record in a metastore, and then meshing up stuff kind of becomes more approachable. And eventually, before predicates, you've mentioned some terms. So yes, there's always a gap of kind of how do I simplify the internals? How do I evolve technology? How do I evolve the way data gets crunched without breaking the simplicity that people got used to? And as you try to join stuff and add data sources together, I think Yelp is just an amazing kind of evolution on how to build that, and the fact that your customers drive your how you deploy data is also unique, and it's really amazing to see that. And you remember, once upon a time, data was this sidekick where you used to look for insight. Yes. Now nobody looks for insight. Now this is your business. Amazing. Thanks for sharing.
Yeah, thank you. This is fun.
Steven, we're about to wrap up. Maybe before we wrap up, any sort of company leader in data, something you that inspires you that you think our listeners should follow?
Well, that's a trap question. No, now your audience should know, like, the sponsor of this podcast is Firebolt, and I first got introduced to Firebolt in 2020, and it's certainly a differentiation product. So I'll kind of give your listener in terms of my kind of passion in the analytics market is how to think about the various engine and what are all the techniques behind those engine. And I kind of give your audience a flavor, right? Amazon Redshift being one of the first to market in terms of cloud data warehouse. They really pioneered that. Like, yeah, you should only charge per use. Like, there's nothing else. You shouldn't pay more when you're not using it. They really kickstarted we can actually have a data warehouse in the cloud, right? Now, of course, your audience may have noticed, 2020, there's a blip in the stock market called Snowflake that's worth $85 billion, like within 5 years. And because they demonstrated that, like, wow, if you can make this data warehouse thing completely limitless, not thinking about storage, not thinking about even what cloud you deployed it in, there's a lot of value in that.
So basically, Frank Slootman is your hero.
Well, I would say, I certainly, not at a Yelp capacity. I follow, many of these organizations have published their paper to, VLDB or Sigmod, and that's how I learn about their systems. I think what Snowflake has really solved is if you have S3 as a substrate, how would you imagine how to build a database? Remember, like, Redshift is an evolution of an MPP system that runs on, virtualized hardware on the cloud. But they did not, build their solution from the ground up to say, what happened if you just have an object store? What to do next? And they certainly have demonstrated that, if you have an object store, you actually don't have to worry about losing data. Now you should make sure that you can actually run queries on the data in a very fast manner. And what they've done, and I think they use this, they have this insight, right? It's like, wow, because it's the cloud, you have limitless elasticity in terms of compute. Let's just use compute to go through the data. And it's a very powerful concept because now you are no longer bounded by how many hardwares you can stick onto your rack. And they are one of the great users of EC2 in the cloud. But I think those classic things we've learned in our database courses didn't disappear, right? So you have a disaggregation. Yes, Snowflake pioneered the disaggregation of data and compute. And technically, BigQuery has done it for a while. They just haven't quite figured out how to market BigQuery to the other customers. And what happened is, during this disaggregation, your data are really far now. So meaning that if you really want to get your data really fast, you have to go figure out how to get the data from S3 to the box at the end. That's still a box. And then suck into the CPU and then analyze the data in your CPU. Your latency is a lot farther now. So you need to innovate to figure out, like, now that your data path is so far away from the CPU, what can you innovate to make it work? And now, what's interesting, right? When Firebolt, talked to me initially to kind of present when they're still stealth about the solution, is like, they're saying that is, well, the last decade, actually, the database community has still moved forward a lot of ideas on data organizations, and how you do your data structure in a many cores environment to be efficient. And those haven't really been exploited by solutions by Snowflake. So when I see kind of Firebolt in terms of how they really, the tricks here is be efficient about where you store the data and how little data you can access. To me, that really show me is sort of a next iteration of where the next cycle of innovation will happen. And certainly people are not sitting still, right? I see Amazon Redshift has matches lots of capabilities of Snowflake. And as Firebolt really show off, the unique efficiency, to the world, you also have target painted on your back. People know like, oh, wow, when customer notice the other person is more efficient and they notice because their bill is a lot lower, wow, that's the next fight. And they will jump right into it.
It's never boring in the data space.
Exactly.
Steven, this has been super, super fun and interesting. Thank you so much. And this is it. Listeners, please subscribe. Click below, above, to the right, to the left. All these buttons of subscribe and follow. Click them so you can listen in to more interesting conversations. Thank you for joining us. See you next time.